Hello mathematicians, welcome to the little corner of the internet that we call Marshable Math. Today's lesson will be factoring quadratics with a leading coefficient of 1. My name is Mr. Marsh, I will be your instructor for today. You're advised to get a piece of paper and a pencil and a calculator or other mathematics tools to have with you as you go through the video, and remember that you are the timekeeper, so if you would like to pause and rewind or maybe even fast forward the video, please feel free to do that. So by way of review, let's discuss a couple things. First of all, quadratic. What is a quadratic? If we're factoring them, we ought to know what they are. A quadratic is a polynomial that has a degree of 2. What that means is the exponent, the highest exponent on x, is a 2. So it would be the x squared. So this is an example here of a quadratic. Next, two-factor. Two-factor would mean to unmultiply or to work backwards to find a number's prime factors. And a factor is something that is multiplied, or that which is multiplied. We're going to need to know that the standard form of a quadratic is in the form of ax squared plus bx plus c, where a and b and c are simply the numbers, the coefficients that are multiplied in through the x terms. In this case, though, we're going to be working with a quadratic with a leading coefficient of 1, so that means our a in this case is going to be 1, and so we simply won't write it because that is a newbie mistake. So to get things started, let's do a little exercise that should be review for most of you. What I'd like you to do is I'd like you to multiply the following together. X plus 3 times x plus 8. So take a moment here, press pause on the video, multiply those two together, collect your like terms, and tell me what you have in the end. Okay, if you're finished by now, you should have something like this. If we multiply these together, we're going to multiply each term in this binomial by each term in this binomial. We should have gotten x squared. X times 8 is plus 8x, and then we would have gotten 3 times x, which is plus 3x. And then 3 times 8, which is 24. We know that these two then are like terms. They go together. We simply combine their coefficients. In the end, we should have gotten x squared plus 11x plus 24. So what we've done is we've multiplied these together. The question for today is now, how do we take something that is already a product and work backwards to find the factors? And if you'll notice, these two are the same. So let's think about this for a second. Pretend that you don't know this existed, and you're asked to factor then this one right here. I want to draw your attention to two numbers that are important. The 11 and the 24. Now there's a relationship here between these two. I want you to think about what it is. May not be readily apparent. But if you look and if you remember how we got those in this one over here, you should come to the conclusion that, oh, we got 24 by multiplying the 8 and the 3. And surprisingly enough, we get 11 by adding the 8 and the 3. So when we're looking to factor quadratics that are in this form, we need to look primarily at the c term here, the number that does not have an x to go with it. So the question I'm thinking in my mind then is, what factors of c then add to give b? And by c, I mean the number that's here in this position, as we see in that template right there. And then the b would be the one here that's underlined in blue. Okay, so what factors of c add to give b? Well, how do I know that it's adding? I'll tell you right now. It's whatever that sign is. Oops, I missed my arrow. Whatever that sign is right there. The sign that's on c tells us what to do with these. But we'll come back to that a little bit more in a minute. So my pattern for doing this is to think about what are my factors of C. So off to the side, I'm going to make a little list of the factors of 24. 24. I always want to be systematic with them to make sure I don't miss anything. And I want to have a real simple way to start. So let's do 1 times 24, and let's just make a list. 2, does 2 multiply into 24? Yes, it does. 2 times 12. 3, does 3 multiply into 24? Yes, it does. 8. Let's see, what comes after 3? 4? Yep, 4 works. 4 times 6. 5? 5 doesn't work. What comes after 5? 6? But we've already got the 6, so we know that we're finished. Okay, now, which factors, when I add them, because the sign on the C is positive, which factors, when I add them, give me number 11? As you can see, it would be the 3 and the 8. So here's what I do. is I come down and I say, all right, it's going to be an X and a 3, and it's going to be an X and an 8. Now I need to think about sign. How do I get a positive 11 when I combine a 3 and an 8? And I hope that you can see that both of these have to be positive. So that when I add them, positive 3 and positive 8 give me positive 11. But when I multiply them, I get positive 24. Okay? And of course, as you can see here, that's what we've done. But look here, we did this when we started off. Okay? How did we get 24? We multiplied them together. And then how did we get 11? We added those pieces together. So basically, we're working the process backwards. Alrighty? So, what I'd like you to do now is I'd like you to try one on your own. So, let me erase this one here. I will leave that up as a reminder. Let me have you try this one on your own now. Let me have you try x squared plus 13x plus 36. So go ahead and try to factor that one. Press pause on the video, and I will give you a moment then to get finished. Okay, back at it. Well, here's what I do. I need to find my factors of 36 that when I add them, give me 13. Okay, so I will make a list of factors of 36. 36, 1, and 36. Now as I'm going through this, sometimes it's good to make a complete list, but sometimes you can be thoughtful as you're going through the list. I need to stop when I find a pair that when I add them give me 13. 1 plus 36, not 13. 2, 18. No, not 13. 3 and 12. Well, 3 plus 12 is 15, but that's not 13. After 3 comes 4. 4 and 9. There we go. 4 plus 9 is 13. So here's my pair that I need, and I can stop. So I'm going to say then x and 4, and then x and 9. And again, how do I get a positive 13? By combining these two numbers. What are the signs? They both have to be positive. Okay? Did you get that? It's fairly simple. Doesn't involve a whole lot of guessing and checking. What you're doing is you're being thoughtful and you're working back through the process that you learned when you went forwards with this method. We're just simply taking the process and going backwards to find our factors. All right, let's try another one. Let's do x squared minus 5x plus 24. Okay, press pause on the video. Take a shot at that one. Okay, back at it. You might have noticed that this has a negative sign, but we'll get to that in a moment. First of all, let's look at factors of 24. 24. I know that I have to add the factors together and get the number 5. Don't worry about the negative at this point. Just worry about the number. We'll take care of the negative as a separate step. Factors of 24. 1 and 24. Nope. 2, 12. Nope. What do we got? 3 and 8. No. 4 and 6. Nope. 5 doesn't go into 24. 6? Well, I've already got 6. Factors of 24 that when I add them give me 5. I don't see anything that works. Can you find a mistake that I've made? I don't think I've made a mistake. Oh, here I am. Sorry about that, a little hiccup there. So anyway, I don't think I've made a mistake. So what do we conclude if we don't have something that factors down into two or more smaller factors? What do we call that? Unfactorable, perhaps, yes, but there's a better word for it. Okay, starts with a P. Prime. Yeah, this is a prime polynomial. All I can do is say, hey, it's just 1 times itself. Okay? So, go through the checklist. See, look, if you've done it right, you've got all your factors listed here. Which ones, if you're doing the math correctly, which ones, when you add them, give you the number 5, none of them work, prime. Very easy to come to that conclusion. Okay? Now, what do we do then if our leading coefficient, or I'm sorry, if our C term is not positive? What do we do if it's negative? So here's an example. We'll discuss this. So consider x squared minus 5x minus 36. Okay? If we had said, well, when the C term is positive, we add the numbers together to get our B term. What do you think we will do here if our C term is negative? Maybe subtract? Let's find out. Okay, let me do my factors of 36. So factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't work, so 6 and 6, and when I've got a double, I know that I'm finished. So do I have factors that when I subtract them give me the number 5? Don't worry about the negative sign here for a minute, just look at the number, okay? If I take the difference of one of these pairs, do I get 5? I sure do. 4 and 9. So let's set up the format then and see what we get. I get an x and a 4, and then I get an x and a 9. And now I need to think, okay, what do the signs have to be? Well, when I combine them, I have to get a negative 5. So how do I get a negative 5 by combining a 4 and a 9? What do the signs on these two have to be? Well, since my negative here has to, when I combine them in the end, I have to have more negatives than positives. Doesn't my 9 have to be negative? A negative 9 and a positive 4? Does that work? Negative 9 plus 4, negative 5? Seems to work. But I got to check and make sure that it works when I multiply them to get my C term. Does a positive 4 times a negative 9 equal negative 36? You bet it does. Okay? Let's try it and multiply it out just to see if we get what we're supposed to. Because the way that you can check to see if you factored something correctly is to multiply it, right? So let's multiply this out. X times x, x squared. X times negative 9, minus 9x. Positive 4 now times x would be positive 4x. Positive 4 times negative 9 is negative 36. And when I combine my like terms, does that give me a negative 5? You bet it does. So the principle here is this, that if the C is negative, we're looking for what factors of C subtract to B. How do I know that it's subtraction? You have to look at the sign that's on your C term here. Okay, subtraction, that one right there. Okay, got it? Let me give you one that you can do then on your own. Almost finished. Let's try x squared minus 10x minus 24. Press the pause button on the video and take a shot at that. Alrighty? What'd you get? Well, let me do my method. I'm going to do factors of 24. So, 24, list them out. Have we done this one already? 1 times 24, 2 times 12, 3 times 8, 4 times 6. Which ones, when I subtract them, give me the number 10? 2 and 12. Okay. Let me put the values in here. 2, I'm leaving room for the sign now because I don't want to mess with that at this moment. X, 12. Now I'm thinking about signs. How do I get a negative 10 from a 2 and a 12? Okay, obviously I've got to have more negatives in the end when I combine them, so the larger one must be negative. So that's going to be negative, that's going to be positive. When I multiply them, do I get a negative 24? Positive 2 times negative 12? Yeah, negative 24. Okay, good job. Now, let me bring up a point. Whenever your C term is negative, you know that your signs in here must be opposite from each other. Okay? How do I get a negative 24? One of them's got to be positive and one of them's got to be negative when I multiply, right? What about this one over here? How did I get a positive 24? Well, these two had to be positive. But remember we did one that actually gave us a negative. If it was negative down here, negative 3 and negative 8, negative 11, positive 24, does that work? Sure, because when I combine them, negative 3 and negative 8, I get negative 11. But when I multiply them, negative 3 times negative 8 is positive 24, because a negative times a negative is a positive. Why? Let me give you one more. Let's do x squared plus 21x minus 72. Go ahead and pause the video and see what you can do with this one. Okay, let's see what you got. Factors of 72. Ah, golly, there's a lot of them. Okay, I'm looking for ones that when I subtract them give me the number 21. All right, I'll go down through the list. 72. We'll be systematic about it here. I might actually need my computing machine here. Obviously, we're going to start with 1, 72. 2, well, 72 is an even number, so 2 times something, I'm betting 36. Okay? Let me check it though. 72 divided by 2, oh yeah, 36. 3. I think 3 might work. Here's what I'm going to do. I'm going to take 72 divided by 3. If I get a whole number, it works. Yeah, 24. 3 times 24, 4. 72 divided by 4, 18. There we go. By the way, do any of these, when you subtract them, give you 21? Oh, look at that. That was the pair right there. I shot past it. Let's just say that you wanted to complete the whole list. 72 divided by 5. Does 5 work? It doesn't. But here's how you can tell on your calculator if you're not sure if the number works or not. Take 72 divided by 5. Notice that you do not get a whole number. You get a decimal. Okay? So if you don't get a whole number, then it's not an even factor. But this is the pair that I want. So I want an x and a 3, and then an x, and then a 24. Now I've got to be thoughtful about how I put the signs in. How do I get a positive 21 from a 3 and a 24? Well, in the end, I've got to have more positives than negatives when I combine them, so the larger of the two must be positive. So plus 24 minus 3. There you go. It's just that easy. I hope you had a good time. Make sure you get your homework done on time. Okay? Homework is like lifting weights. If you don't lift your own weights, you really don't get any stronger. Okay? Best of luck. I'll see you next time.